All right, it is Tuesday, January 5th, 2021. This is Chemistry CP, Mr. Turek, trying to present the PowerPoint with the title of Nomenclature, Cations with Multiple Charges. Just before I started recording, I tried to draw students' attention to the periodic table. Without bringing it up on the screen, I'm going to repeat what I was saying verbally. All the atoms in the first column of the periodic table, the alkali metals, will always choose to give away one electron as part of any arrangement in becoming a molecule. They will always become a +1 charge or 1 plus charge. All of the elements in the second column of the periodic table will always choose to give up 2 electrons as part of any arrangement in which they become molecules. So beryllium, magnesium, calcium, they will always have a 2 plus charge. Way over on the right side of the periodic table, of course, the noble gases will not be involved in any chemical reactions. They are non-reactive. But right next door to them, the halogen column, fluorine, chlorine, bromine, iodine, astatine, they will always choose to gain 1 electron and become a 1 minus anion as part of forming a molecule. Next door to them, oxygen, sulfur, selenium, and tellurium will always choose to gain 2 electrons in the process of forming a molecule. Next door to oxygen, nitrogen and phosphorus will always choose to gain 3 electrons in the process of forming a molecule. And the last element that we can put into this definite list is carbon, will always choose to gain 4 electrons in the process of forming a compound. All right, so I'm switching to earbuds so that I can hear you without any risk of it being accidentally recorded. And I'm going to call in random students quite a bit today. So the rhetorical question, which elements have multiple charges? The answer is most elements do. The transition metals, I remind you, are the middle part of the periodic table as you look at it. And the heavier elements means towards the bottom of the periodic table. You might have noticed in the list that I was reading off, when I said, for example, that the halogens always gain 1 electron to become a 1 minus charge, I didn't read the entire list. I read fluorine, chlorine, bromine, iodine, and astatine. But underneath astatine is element number 117, tennessine. It is so heavy that it falls into this category on the slide of maybe it can have multiple charges instead of always being strictly a 1 minus charge. The chalcogens column that I read off, I said oxygen, sulfur, selenium, and tellurium will always have a 2 minus charge. But underneath tellurium, element number 84 is polonium. It is a heavy metal, not the rock band. So maybe it isn't locked into strictly only being a 2 minus charge in its arrangements. The same can be said on the column that begins with nitrogen and phosphorus. Arsenic was not on the list of single charge ions. Silicon was not on the list after carbon. So you can see on the slide when they refer to the heavier metals, they mean as you go towards the bottom of the periodic table, the higher period numbers. They tend to be able to have arrangements where they give away not just one choice of number of electrons, but multiple choices. That begs the question, how do you figure out what the charge is? And so there's two terms. I want to remind you what they are. A neutral atom is just a neutral atom. If I add electrons to a neutral atom, we call that an anion. It has more electrons than protons, and therefore it has a minus electrical charge of some magnitude. If I start with a neutral atom and I remove electrons, we call that a cation, the last word on the slide so far. A cation is a positively charged ion. That means it has more protons than it has electrons. The rules for writing and naming compounds includes a rule that says you always write the positively charged piece before you write the negatively charged piece. That's why we always say that table salt is sodium chloride. The sodium is positively charged. It is the cation. So it's always named and written first. The chlorine is the negatively charged ion. It is the anion. It is always written last. Sodium chloride is always written and spoken in the order of the sodium first because it's the cation, and the chlorine last because it's the anion. Here's a new situation on the slide. Fe is iron. Cl is chlorine. The subscript 3 after the Cl means I need 3 chlorine ions to build this molecule. Over on the right, the subscript 2 after the chlorine means I need 2 chlorine ions to build that molecule. How do we name them? How do we write them? How do we tell which one it's supposed to be? That is part of what you will now begin to see. Because chlorine is a halogen, it will always be a 1 minus charge. And if I have 3 chlorines, each with a 1 minus charge, then my 1 iron must be a 3 plus charge, matching the example on the left. Looking at the example on the right, each chlorine is always a 1 minus charge. The subscript 2 tells me I need 2 of those chlorines, each one of which has a 1 minus charge. To balance the molecule and make it all electrically neutral, the iron must be in a 2 plus electrical state. It must be a cation with a 2 plus charge. So, what is the charge of each cation? This is where life gets complicated. Try to follow along and master this. This is a molecule written as a formula. The CO is not carbon and then oxygen. No, 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 no. Anytime it's a lowercase letter, that means it is the second letter or even third that goes in the name of the element. So the element is CO, which is cobalt, number 27 on the periodic table. After cobalt, there's chromium with a subscript 2, and after that is oxygen with a subscript 7. Right away, you should agree to yourself that there are more than 2 elements in this formula. There are 3 elements: cobalt, chromium, and oxygen. If there were only 2 elements, then we would call that a binary compound. And the rules for binary compounds, such as table salt, says write the name and write the cation first, the positively charged metal. Then write the name of the negatively charged anion last, but when it is only 2 elements, change the ending of the anion to IDE, ide. That's why we don't call it sodium chlorine. Instead, we call it sodium chloride, because table salt is a binary ionic compound. The chlorine ending changes to IDE. Looking at the example on the screen, it has more than 2 elements. So this is not a binary compound. Binary means 2. Instead, you have to look at the chromium and the oxygen and recognize that they form a group, a single unit called a polyatomic anion. Go look up your reference sheets and search through them looking for 2 pieces of information. I want the name of Cr2O7 and I want the electric charge on Cr2O7. As you look, I'm going to remind you, okay, so you're looking for the formula Cr2O7 on any of these reference sheets. When you find it, a superscript after the 7 or after the oxygen will tell you what the electric charge is. If it's just a dash, that means it is a 1 minus charge. If it is 2 dash, that means it is a -2 electric charge, and so forth. If it says plus, then it is a cation, and just like with the minuses, a single plus superscript means it is a 1 plus electric charge. A 2 plus means it is a +2 electric charge. I'm now going to randomly select a volunteer from our class to answer those 2 questions. Question 1, what is the name of Cr2O7? And question 2, what is the charge of Cr2O7? Random volunteer, Alessandro. Please acknowledge if you heard your name. All right. I'm standing by while you are searching through your reference sheets, trying to find the element group, the polyatomic anion that goes with Cr2O7. Still standing by. Okay, go ahead. What did you find? Excellent. Excellent. I agree with you completely. Dichromate is its name, and it has a 2 negative electrical charge. Okay, so for all you poor souls trying to follow along, it's out there someplace. On the common ions listed by charge, it's in the third column under negative ions, 2 minus charge, dichromate. On the reference sheet that I said was list of polyatomic ions, it's about the 5th line up from the bottom, dichromate. On the reference sheet with the title list of common ions, right column, table title is polyatomic anions, and it is, I forget where it is. I'm looking. Oh, it's about the 5th or 6th one up from the bottom, right hand column. 1, 2, 3, 4, 5, 6, 7. It's the 7th one up from the bottom. In every case, it shows that it has a 2 minus electrical charge. Now, thinking caps on, children. I have one group of dichromate. Dichromate will always be 2 chromiums and 7 oxygens tightly linked together to create one group. If I need more of those groups, I would show that by putting the Cr2O7 inside of parentheses. In this case, I only need one of them. And one dichromate has a 2 negative charge. The cobalt has to cancel that 2 negative charge. So speculate, what do you think is the electric charge on the cobalt? Mindy. Interesting. And Hannah, do you agree with that? Hence, I seem to have job security as a teacher. So dichromate is a group. The group has a 2 minus charge. I have one of those groups. I have one cobalt. That cobalt has to cancel the 2 minus charge. Therefore, the charge on the cobalt is 2 plus. Stare at the answers here on the screen. Cr2O7 dichromate is a polyatomic anion with a 2 minus charge that we found on the reference table. After we found it, then we could figure out that the cobalt must cancel that 2 minus charge with its own 2 plus charge, so that the 2 minus added to the 2 plus add up to 0. Luckily for you, our 3-minute break timer just went off. Whoops. I'm allegedly doing the correct tab now. Wow. Here we go. Cu is not Cornell University, although it's tempting to think it is. It is actually the chemical symbol for the element copper. P for phosphorus, O for oxygen. Count them. 1, 2, 3. That means there are more than 2 elements in this compound. That means this is not a binary compound. That means the phosphorus and the oxygen form a polyatomic anion. I know it's an anion because it's listed last. I know it's polyatomic because there's more than 2 elements listed in this formula. So go to your reference sheets and find the name and charge for the polyatomic anion PO4. You're looking for PO4. I want the name of it and I want the charge on it. It is going to be a polyatomic anion. Random volunteer, vanity. Acknowledge you know I called your name. Go ahead and spell it. Yes. For the PO4. Okay, and what's the charge on it? Excellent. So it's called phosphate and it has a 3 negative charge. That is a tight group and the group cannot be broken apart. This group has 3 more electrons than it has protons. If we were to draw this Lewis structure, it would probably be a phosphorus atom in the middle, surrounded by the 4 oxygen atoms as a group. Great. It has a 3 negative electric charge. As you look at the screen, it shows a subscript 3 after the symbol for copper. That 3 means we need 3 copper atoms to combine with this phosphate polyatomic ion, anion at that, to create a neutral molecule. And I'm not an expert on calling them molecules or compounds. I think table salt is called a compound, and these are ionic, so this is probably a compound. Okay, so thinking caps on. If one phosphate group has a 3 negative charge, and I'm using 3 coppers to cancel the 3 negative charge, what do you think is the charge on each one of the 3 coppers? Random volunteer, Samantha. The question is, what would be the charge on each one of the 3 coppers? Together, the 3 coppers cancel the 3 minus charge from the phosphate. So what would be the charge on one of those 3 coppers? Esther, do you agree with that? Esther, do you agree with that? No, your mic is not working. You can type your response in the chat, Y or N, yes or no. Yes, you are. Yes, I agree with that. Oh, you weren't talking about yourself. Great. I was just wondering, do you agree with your classmate? So do I. Excellent. Good job. Phosphate, the polyatomic anion, has a 3 minus charge. To cancel that, I needed to use 3 coppers. That means each one of the 3 coppers had to have had a 1 plus charge to make it all work out. Oh man, here's a new one. PB is not peanut butter. Instead, it is lead. O is oxygen, H is hydrogen. And there's 2 things that make it obvious this is not a binary compound. Obvious number 1, it has parentheses. Anytime you see parentheses, it clearly is not going to be binary. It clearly must have more than just 2 elements in its formula. Clue number 2, just count how many different elements you see. Lead is 1, oxygen is 2, hydrogen is 3. 3 is more than 2. So this is not a binary compound. Inside the parentheses is a polyatomic anion. Go find it. I'm going to ask you 2 pieces of information. What is its name? What is its charge? The charge is the superscript after the H. What is the name of OH? And what is the charge on one of these OH? Saeed. Well, I wonder if one of your classmates can step up and help on that one. Emily T, perhaps? Have you found it on the reference sheets? Can you tell us what the charge is on it? And Saeed, I kind of agree with you. The quality of the reference sheets that I shared with you students, sometimes it looks like it's poorly printed, where it's hard to read for sure whether it's saying a plus or a minus, but try to work with it the best you can. Maybe I can find a higher quality um, rendering of the reference sheets to share with you students. Emily, any response? All right, Jessica, what's the charge on hydroxide? Yes, it is. Thank you. Okay, it's 1 minus. It is right there, isn't it? Wow, you're ahead of me. I goofed. I didn't mean to put it on the screen. Thank you for reading my screen for me. I guess I should just jump to the punchline. All right, kids, as you look at the answer key on the screen, 1 hydroxide polyatomic anion has a minus charge. That is a group. The parentheses are telling us we need more than one hydroxide group. The subscript 4 tells us how many hydroxides we need. It tells us we need 4 hydroxides. You can't mess with the group. You can't mess inside the parentheses. The 4 outside the parentheses tells us we need 4 hydroxides. If each hydroxide is a 1 minus, and I need 4 of them, then to cancel them out, the lead has to be a 4 plus charge. Oh man, let's see if I can call on you students before I show you the answer key. SN, S2. SN is tin. S is sulfur. I'm counting only 2 elements. Therefore, this is a binary compound. The rules for binary compounds are you list the cation first, that would be the tin. You list the anion last, that would be the sulfur. And when you say the name, you change the ending of the anion to IDE. So I would not call this tin sulfur. I would call this tin sulfide. Tin sulfide. Based on your understanding of the periodic table or finding it on the list on the reference sheets, what is the charge on one sulfide ion? Eric L. What is the charge on one sulfur ion? And Skyly, do you agree with that? In that case, you have to alter an alternate. I agree with you, Skyly. 2 minus. All right, next question. If each sulfur is 2 minus, and I need 2 sulfurs, what is the charge on the tin? Emmanuel C. Excellent. I know I should have called on someone else to see if they agreed with you, but you are correct. So I just jumped to the answer key. There it is. 4 plus. Excellent. There's a technique called crisscross for working out the values of the subscripts, but I don't think we'll get there today. Instead, we have to deal with writing the name correctly. How do you write the word for this compound if it could have a +2 or a +3 or a +4 or a +1 or who knows what it's doing? The answer? Use Roman numerals, particularly when you're in Rome. Roman numeral 1, 2, 3, 4. Now this list says 5, 6, etc. In my limited experience, I can't really imagine a situation where a cation would want to give away any more than 4 electrons. So I don't think we're ever going to see a Roman numeral 5 or Roman numeral 6 or etc. situation. I think at most we would see a Roman numeral 4. Roman numeral represents the charge of the cation. We only use the Roman numeral for the cation. We don't bother using Roman numerals for the anions, only for the cations. So that iron with a 3+ charge would be written out as iron Roman numeral 3. And iron with a 2+ charge would be written out as iron Roman numeral 2. Absorb this slide because from now on, you have to use this information. Ready? Name this. It has 2 elements. Ni is nickel. Cl is chlorine. Look at where chlorine is on the periodic table. You should be familiar enough to recognize its atomic number 17. It's a halogen directly underneath fluorine. It's also listed on our reference sheets. Random volunteer. What is always the charge on one chlorine atom? Ryan. Emily C., do you agree? So do I. All right, next question. If every chlorine is always a 1 minus, and I have 3 chlorines, what is the charge on the nickel? Amber. Before I call on you again, I'm going to turn down the volume on my speakers. And finally, what would be the name of NiCl3? Giselle. Ta-da! Well done. Another one. As you look at this, the parentheses immediately tell us that that is a polyatomic anion inside the parentheses. Go find it. You have 2 questions you need to answer. What is the name of it? And what is the charge on it? The name will be listed next to the formula for it. The charge is the superscript after the CN. Random volunteer? No more students to pick from. That doesn't seem fair. Emmanuel C. What is CN? And what is its charge? Nice. Skyly, what's it called and what's its charge? It's near the top on the sheet called List of Polyatomic Ions. It's in the right column on the sheet with the title List of Common Ions. On the sheet with the title Common Ions Listed by Charge, it's in the 3rd column near the top. Yes, and what's the charge on it? Yes, cyanide, the deadly poison that they use in the movies to kill off either good or bad guys or innocent people. Cyanide. It has a 1 minus charge. That is a tightly bound group of carbon triple bonded to nitrogen. They're so tightly bounded to each other. For a long time, chemists thought it was just one element. They didn't realize it was just carbon and nitrogen tightly grabbing each other. Outside of the parentheses, the subscript 3 tells us that we need 3 cyanides, as if one wouldn't kill you. 3 cyanides. So what would be the charge on the cobalt? Alyssa. Hannah, do you agree? And therefore, volunteer, name that compound. Ryan. Child, name number 2. Ta-da! That is correct. Cobalt 3 cyanide. But wait, there's more. As you look at this, there are no parentheses, but there are more than 2 elements. So therefore, the carbon and the 3 oxygens must be a polyatomic anion. Go find it. I have 2 questions. What is it called? What is its charge? CO3. Find it. What is it called? What is its charge? Ester. It's still not working. Oh, child, that wounds my spirit to read that. I'm gonna, I'm gonna move on, Esther. Jessica, what is it called? What is its charge for the CO3? Esther, yes or no? Do you agree with that? Okay, so do I. I guess you're back off my naughty list for the moment. So, CO3 is called carbonate, and each group has a 2 minus charge. That means it has 2 more electrons than protons in that group. There are no parentheses, so I only need 1 carbonate to make this thing work. Therefore, what is the charge on that copper? Giselle. And finally, name the compound. Emmanuel M. One 1000. He's Googling his friend. He could just ask his little sister, who probably understands this so well that she will help him with his homework in the future. Hmm. Seriously, you're Googling it? Maybe. No! Just answer the question. Best guess right now. I see. Okay, I'm moving on. Emily C. Name number one. Amber, do you agree? Typical Amber. Oh man. That's because you went and dug up the PowerPoint that I already attached to this classroom before the presentation began. Oh, I see. It's because you Googled it. I see. Oh, it's because your little sister taught you how to do this. Children, number two, there are parentheses. Therefore, the OH is a polyatomic ion, one that we have seen before. So if you've bothered memorizing this stuff, you can tell me the name and the charge on the OH that is in parentheses. Or you're going to have to go find it right now. Samantha, your name came up. What is the OH called and what is its charge? Excellent. That is right. You got it perfectly nailed. Each hydroxide has a -1 charge. It's inside of parentheses. Outside of the parentheses is a subscript 3, telling us we need 3 hydroxide groups. One hydroxide is a -1 charge. We need 3 of them. So volunteer, what is the charge on the chromium? Vanity. Acknowledge that you know I called your name. Vanity. Now I can. Name number 2 without Googling it. We already established that the OH is hydroxide. It has a -1 charge. I need 3 hydroxides. What is the charge on the chromium? We established it is a 3+ charge. And you're doing the last step, which is just writing out the name, the blue text. How do you name number 2? Ah, ding. Okay. Emily T. Anything from V? Mm, Eric, name it. Repeat. I was really hoping that you would name number 2, the entire compound. Chromium, Roman numeral 3, hydroxide. We are at the end of the period. I am shutting off the recording that was taking place once I figure out the button that does that.